Hi and a very good day to everyone. We are Team Flyhawks Revenants from KPM-Guru. I'm Jenison and I'm the coder.
I'm Ellison and I'm the idea giver.
I'm Kyson and I'm the assembler.
To revitalize the hawker culture, which represents the driving force of urban microeconomics and tourism in Malaysia, Hawk is an affordable and multifunctional robot created by our team to modernize the food sector and secure local livelihood. Hawk will eliminate major financial holes for street vendors such as sudden resource depletion, unexpected weather, hygiene risks, and physical strain on aging entrepreneurs. This allows small businesses to maximize their profits and scale up sustainably, which will ultimately aid the economic growth for Malaysia. The aim of this project also aligns perfectly with SDG 8, decent work and economic growth. Due to operational vulnerabilities in the street food sector though, hawkers face constant financial losses that stop them from growing. Our research led us to find that while hawker stalls are the backbone of local tourism in Malaysia's urban economy, over 40% of these micro-enterprises struggle to scale up. Their low profit margins are highly influenced by unpredictable factors like sudden bad weather and running out of fuel, which cause massive leakages in their daily earnings. Our vision was to develop a solution capable of performing various tasks aligned with the SDG objectives, where in this case SDG 8 for decent work and economic growth. Our goal is to actively boost economic productivity, encourage the growth of micro-enterprises, and work alongside small business owners to assist them in upgrading their business capacity. We aim to eliminate financial holes, unlock higher revenue by allowing vendors to easily access popular tourist areas, and ultimately foster a more thriving national economy and open up sustainable job markets with the help of our solution, Hawk. Some of the functions our robot is equipped with include smart fuel monitoring, which constantly tracks the content of the cooking gas tank and sounds an alarm when it is running low. This gives the vendor plenty of time to get a replacement before a busy customer rush, preventing any interrupted cooking or lost sales. Hawk also features a smart mobility assist that gives a power boost to the wheels whenever it is being pushed up steep slopes or hills. Additionally, this completely removes the exhausting physical strain for elderly vendors, allowing them to safely reach the busiest, most profitable selling spots. To handle Malaysia's volatile weather, Hawk automatically rolls out its overhead canopy the moment it detects extreme afternoon heat or sudden rainstorms, protecting raw food from spoiling and keeping the vendor healthy. For active hygiene maintenance, Hawk automatically guards the waste bin area and activates a protective barrier if pests try to get close, saving the vendor from heavy health fines. Finally, because the Hawk is built using affordable, eco-friendly materials, it keeps production costs incredibly low, making it accessible to low-income individuals who lack startup capital.
Our build is divided into three main parts: the canopy, the trash bin, and the body. So let's start with the canopy. Its movement is powered by a servo motor, a gear, and a gear rail. The servo motor is connected to pin D9. When it spins, it drives the gears, converting that rotational motion into a linear movement along the rail. Because the rail is attached to the canopy that is clamped in between blocks, the whole system slides in and out smoothly. We also added guards at the ends of the canopy to prevent it from slipping out. To top it off, we mounted a servo on D9 to spin a sweater that chases away flies. Moving on to the trash bin, we have attached an IR sensor to the top wired to pin A2. The moment it detects movement, it flags the system to trigger an LED and a buzzer, connected to pins A0 and A1. The trash bin is attached to the opposite end of where the canopy's servo motors is located to balance the build. Lastly, the body features of a DC motor on M1 powering two wheels. We actually choose a single motor for both wheels on purpose to prevent the annoying wheel drift that often happens with two independent motors. The wheels behind are also shorter than the wheels in front to evenly spread the weight of the build and to prevent the wheels from coalescing under the strain. A touch sensor is wired to A2 that senses the weight of the gas tank to determine its fullness. Finally, we have yet another touch sensor to pin A4 that obtains user input for the user to control all the components. Our coder will explain more in detail how that logic works.
To detect the capacity of a gas tank, a touch sensor is used. When weight is applied, the circuit will break and the code will run, alerting the merchant that their supply has depleted. Clicking the button once will toggle the fly repeller, and it will move periodically to chase off flies. Holding down the button toggles the canopy. It turns the servo motor to transfer the mechanical energy to the canopy, thus extending it. A state toggle is used to keep track of the canopy status. Double-clicking and holding down the button will enable motorized assistance. Holding it longer will increase the power of the motor, and it is accompanied by beeps in increasing pitch for user response. Button consists of two logic checks for single and double clicks. We utilize asynchronous code for the core loop of the build. We implemented this framework as the build requires multiple functions running simultaneously, while button actions require timers to register click types, as they only have two input states. Unfortunately, Studio's IDE only supports wait functions that block code from completing, so only one task can happen at a time. Hence, we run a global timer to control each aspect of the build's functions. Hawk has a built-in fly repellent system to chase off flies during service. The active defense barrier against pests near the car's waste storage area also automatically keeps rodents and insects away from the food preparation zone. This way, it maintains a clean environment that complies with urban health standards, ensuring the health and safety for the community while maintaining customer confidence.
Hawk monitors the contents of the cooking gas tank and alerts the vendor with a distinct alarm before it completely runs out. This prevents vendors from having to abruptly stop cooking during heavy customer rushes, ensuring they never have to turn away hungry customers and lose out on peak hour daily income. Hawk will automatically roll out its built-in canopy during intense afternoon heat or sudden tropical rainstorms. By doing this, it protects raw food ingredients from spoiling, while safeguarding the vendor's physical health from heat strokes and sicknesses. Hawk uses a motorized assist to give the wheels a power boost whenever the cart goes up steep hills. This completely removes the exhausting physical strain of pushing heavy loads, especially for elderly vendors. By making travel effortless, it allows them to easily move their businesses to high-income, busy areas like schools, carnivals, or transit hubs that were previously harder to reach.